Okay, in this video I'm going to work through the design of valid board. And as I said, this is paradoxically the hardest function in the whole program. But by working systematically, I'm going to get there bit by bit. The first thing I'm going to do is, let me start to write a template. And what am I going to put in this template? Well, I have to produce true if no unit on the board has the same value twice. And otherwise, I'm going to produce false. What I showed you in the last video, what I reminded you of in the last video, is that there is this constant here, units, which is the list of all the units. So really what I'd like to be able to do here is operate on that list of units to make sure that all of them are valid. So I sort of wish that I could template this somehow as doing something on the list of units. Now this is a slightly different template than before, but we can always put constants into a template to say that we want to operate on those constants. And now I'll just go directly to wishing that I could say something. And what I wish I could say here is I wish I could say that all these units are valid. So I'm going to write a wish list entry for that, and I'm going to do it inside a local because I think there's going to be several of these helper functions. I don't have to do this in a local. I could do this at top level. I'm just going to do it in a local to show you that I can. I'll say that valid units is a function I wish I had. And well, what's its signature going to be? Well, I'm giving it a list of unit because that's what units is. Units is a list of unit. And I want it to give me back a Boolean. I want it to give me back true if all the units are valid. So that's a reasonable stub for it. And now I've made some progress because I've said that validating the entire board means validating all the units. Let's keep going. How am I going to template valid units? What goes here? Well, it's ... LOU, that's the template for starters. But how do I template it? Do I template it according to list, operating on all the units in this list of units? I could template it that way. But what I'm going to remember here is that this needs to make sure that every single unit in the list of units is valid. And that's an AND map. That's an AND map. So I'm going to template it as a call to AND map. Now I've templated it as a call to AND map. I need to fill in the dots. Well, in AND map, the dots in this case, the signature of the dots, this function right here, the function that we stick in right here, has to have the signature unit to Boolean because I'm calling AND map with a list of unit. And AND map is going to call this function with each of the units in turn, and the function has to produce a Boolean. So here what we need is a function that checks whether an individual unit is valid. Well, we don't have one, but let's wish for one. I'll wish for it right here. That's the stub for it. And its signature is that it consumes a unit. I'm going to write this way just for fun. Unit to Boolean. So this function, let me get rid of this blank line here. The first function, valid units, consumes a list of unit and produces a Boolean saying whether all of them are valid. The second function that I wished for, valid unit, consumes an individual unit and produces a Boolean saying whether it's valid. How am I going to template this? Well, I could go look at what a unit is. A unit is a list of pos. Okay, a unit is a list of pos. But what does it mean for a unit to be valid? It means that the unit does not have the same value twice. Here's an example that uses the unit for the third row of a board. Here's the unit that lists all the positions of the third row, and here's the actual board and its third row. If I use that unit to read all these values, to read the contents of the third row, I would get a list like this. Now I need to throw out all the falses because I'm allowed to have more than one false. If I throw out all the falses, now I just have the values in that row. And if there's no duplicates there, the unit's valid. Let's see, I've got to read out the unit. I've got to get rid of the falses or keep only the numbers. And I've got to make sure there's no duplicates. That's three distinct operations on the entire value at each step. That's a function composition. Let's template this as a function composition. Let's see, the first thing we need to do is read the unit, u. And once we've got the unit, we need to keep only the values. Right? I could wish for a function called get rid of the falses. It would be the same, but I'm going to wish for a function called keep only the values. And once we've kept only the values, we need to make sure that there are no duplicates. We need to make sure there's no duplicates. So that's a function composition wish. And it might look a little more clear if we do the line breaking like this. I've wished now for three functions. Let's write the entries for them. Define read unit of u. Okay. That's going to produce a list of values or false. So we'll stub it as producing empty. And this goes from unit to list of val or false. And keep only values, of one of these lists of value or false is going to produce a list of just the values. So this consumes list of val or false and produces list of val. And no duplicates. This consumes a list of val, and it produces a Boolean. To say whether there's no duplicates in there. So I'm just wishing away. Well, let's see, read unit. Read unit consumes a unit, and fix my line breaking here a little bit. And how am I going to template this? It consumes a unit. And remember, a unit is a list of pos. And it's got to read all of those values. So I could template this according to list, because a unit is a list of pos. But what I've got to do for every single one of those poses is read its value out of the board. Read from the board the value of that position. I've got to do it for every single pos in the unit. This is a map. I'm going to template it as a map. I'm going to map something over the unit. Now what am I going to map over the unit? It's some function that consumes a pos and reads that position from the board. Let's wish for that. This is a function that consumes a pos and produces what's sitting in the board at that pos. So it's going to produce either a value or false. How am I going to template that? Well, let's see. It's definitely got the pos to work with. And reminding ourselves about what a pos is, go all the way up here. A pos is a natural from 0 to 80. So if I template this according to the template of that natural, it's an atomic, non-distinct, I put ... p. Now what does this function need to do? Okay, it needs to, we can put it right here if we want, produce contents of board, and by board I mean this board here, the board right at the top, produce contents of board at P. How do I do that? Oh, well, that's easy. Remember, we have this primitive way down here, read square, that produces the contents of a board, produces the contents of a board at a given position P. Let's remember the order of arguments to it. It should be board and then position, and it is. So this is just read square board and P. Hey, I finished a function without wishing for another function. That was kind of great. All these ones up here are done. Ooh, there doesn't really belong a blank line there. All these ones up here are done. These are the only ones that I still haven't completed. I could have maybe been putting bang, bang, bangs in here to keep them more clear. Let's see, keep only values. This consumes a list of value or false, and it produces a list of value. How am I going to template that? Well, this is a filter of some sort. Filter ... LOVF. I'm going to template that way. Now I need to remember what a value is. Let me go look. Well, value is a natural from 1 to 9. So let's see, go back down here to keep only values. I'm consuming a list of value or false, and I need to produce just the values. And values are naturals from 1 to 9. Oh, this is easy. I'll just filter this with number question mark. Number question mark will produce false every time it's given false, and it'll produce true every time it's given a natural from 1 to 9. So this will keep just the numbers. Seems like I'm getting close. What about no duplicates? Let's see, no duplicates consumes a list of value, and it needs to produce true. Let's take a moment to write out its purpose. Produce true if no value in LOV appears twice. How am I going to template that? Well, to see whether something appears twice in a list, I kind of have to go through every element of the list and make sure that it doesn't appear anywhere in the rest of the list, right? Because if I check every element and make sure that it doesn't appear again later in the list, then I'll know there's no duplicates. I don't need to know whether something is duplicated twice. I don't need to know whether something, I don't need to ask the question, well, does this thing appear earlier in the list? If I just ask the question, hey, for every element of the list, does it appear again later? I'll find all the duplicates. Notice what I just did here. I just did the example step of the HTDF recipe. I'm not writing check expects because I'm not defining a function at top level. And I'm not even writing a complete call to no duplicates. But what I'm doing is I'm writing down examples of data that no duplicates is going to have to consume and using those examples to help me figure out what to do. Remember what I said about the recipe. You don't always have to use all of it. But here, this function got a little hard on me, and so I started using a bit more of the recipe. I pulled in the examples. I've been using the signature all the way through here. I used the purpose a couple times. Here I'm using the signature, purpose, and some examples, even though I'm kind of just writing the examples on a piece of scratch paper. So it seems like I need to go through the whole list, and I need to go through the whole list doing something a little different than map or filter or folder do. So I'm going to have to use the full-on list template here. Cond empty lov something else, oops, let's put this purpose up here where it'll do us more good. Else something with first of lov and no duplicates of rest of lov. I'm just writing the list of template from memory at this point. Okay, let's fill in the template. Let's see, if I get to the end of the list and I haven't found a duplicate yet, then it means there are no duplicates. Yay, fantastic. Let's produce true. Otherwise, what I need to ask somehow is I need to ask the question, hey, does this thing appear in the rest of the list? Does the first appear in the rest? I need to somehow ask that question. So there's a specific question I need to ask there. Does the first appear in the rest? Now let's see, the first will be a number, but the rest will be a list. So I'm operating on a list here. So the operating on arbitrary size data rule comes in. This ... has to be a function. And we've seen functions like this before. Earlier in the course, we wrote some functions that we gave them names like contains to check whether a string appeared in a list of string. Turns out there's a built-in function like this you can use in BSL and ISL called member. Member is just the built-in version of contains. It tells us whether its first argument appears in the list that's its second argument. So there's the question. The question is, if I find the first thing in the rest, oh, there's an if here for sure. So if I find the first thing in the rest, then that's bad. That means there was a duplicate. So since I gave this function the negative name, I got to produce false. The answer to the question, are there no duplicates, is false. I've just found a duplicate. Otherwise, we do the natural recursion. Let's see, are our parens balanced here? Give it a go. All tests pass. And I believe, have I commented out the board tests? Yeah, these board tests are uncommented. So all the tests are now passing. So look, that function was a little bit complicated. And I walked you through the I made no mistakes version of it. There's no way you were going to get to the design of this function just as quickly as I did. There's no way you were going to get to the design of this function as quickly as I just did it. So don't be discouraged if you're sitting there going, there's no way I would have done that as quickly. That's not my goal. What I would like you to be able to do is to see how all I did to produce it was follow the design recipes that we've learned in this course. Now, there's some cases where I chose to template according to AND map, for example, and you might have chosen to template according to list of unit. That would be fine. You'd get there too. It'd take you a little bit longer to get there because AND map is quicker than basically doing a concrete version of AND map, but you would have gotten there. Okay. You might not have templated it according to a 3-function composition right away. That was going to cause you a bit more trouble, but you would have gotten there. What I need you to be able to do at this point is go back through this and see that this was a reasonable scenario and see why I made each choice I made at each point. But this was a hard function. It's the hardest single function we've seen so far this course. In fact, it didn't end up being a single function. It ended up having 6 helpers. The key point is that the method we've been learning really did help me get there. So go through this again, and then we'll give you a problem to work on.